We're asking this question to find the critical points of the function f of x, which is defined as x squared times x minus 3. Now, there are two criteria in order for a point to be a critical point. The first one is it has to be a location where the derivative doesn't exist, and also a location where the derivative equals 0. So in order to be able to do any of these, we need to find, well, what is the derivative? There are two ways we can find the derivative here, and I'm going to show both quickly. The first method is by using the product rule. As a reminder, and I'm going to write this on the left here, the product rule tells us that if we have two functions and we're trying to find their derivative, and they're being multiplied, f prime g plus fg prime. And so here my f is x squared, so I want the derivative of that, so that's going to be 2x, and I keep the original function the same, plus I keep the original function there, and I define the derivative of x minus 3, which will just be 1. Here we can solve this out. This becomes 2x squared minus 6x plus x squared, which will give me 3x squared minus 6x is the derivative. So that's one way that I could go about finding the derivative. Another way would be to distribute the function at the very beginning. I'll show that here. I can rewrite f of x. If I distribute here, I get x cubed minus 3x squared. And then so the derivative, I would just apply the power rule. 3x squared minus 6x. And as you can see, they're the same thing either way. One is if you observed the shortcut, the other is if you didn't. Either one gives you the same answer. So we see that the derivative equals 3x squared minus 6x. Now the next goal is there anywhere this doesn't exist? No. 3x squared minus 6x, those are continuous functions. There's no denominators, there's no logs, there's no radicals, there's nothing that's going to cause problems, so this is where it is. But is there places where it equals 0? So let's figure that out. 0 equals 3x squared minus 6x. Now I see on the right side that I can factor. So I can factor out a 3x. So I'm left with x minus 2. And here I'm going to use the zero product property. I see that two things are being multiplied to make 0, so that means one of them must be 0. So 3x equals 0, or x minus 2 equals 0. Here I'm going to divide by 3, so I get x equals 0, and here I'm going to add 2 on both sides, so I get x equals 2. And we find that these are the two critical points, x equals 0 and x equals 2. We don't know exactly what's happening there, but we do know that something special might be happening here with this function at these 2 points, x equals 0 and x equals 2.